So, good afternoon. One more in the waiting room. We'll go ahead and silence phones. So, I think I told you the last time I was here, I did not prep as well as I could have for the ACT. I did okay, but with practice, it would have been better. But in the interest of preparing for teaching you guys, I have been going through as many practice tests as I can. And one of the more interesting things was trying to break down exactly where you get the most questions from. And geometry has a lot, just basic calculation has quite a bit, and those should be the pretty easy ones. But the one that came up over and over again is number sense. And that's just being comfortable with how you can manipulate numbers. What operations you can do, what operations you can't do, just being comfortable with what numbers mean. So I also gave myself an ACT test. I sat down with the calculator for an hour and was trying to see if I could do it. I missed 2 problems. One of them was a super annoying, I dropped a negative sign. And the other one was this. And I don't know if I just have remembered wrong or if I was actually taught wrong. But looking at this problem, if you have 2 natural numbers, A and B, and you add them together, which set does that sum or that answer belong to? So if you take 2 natural numbers, the natural numbers are the counting numbers, 1, 2, 3, 4, off to infinity. Are they integers, the sum? Yeah. The sum will be an integer because the sum, honestly, will still be a natural number. Will it be a real number? Will it be a rational number? Yes, all real numbers are rational numbers. Will it be a complex number? The head shaking got really hesitant. I was confident. I was wrong. In fact, it is a complex number. Even though there's no I in sight, a complex number by definition says that it can be written as, that's not good. It's going to drive me nuts all day. A plus bi, and it's perfectly fine if that number is 0. And so any natural number could be written as A plus 0i. And I was taught that wrong. I thought complex numbers were off in their own little category and they had to have both a real part and an imaginary part. But no, any rational number can be written as a complex number, and any imaginary number can be written as a complex number. For instance, if I have 0 plus 5i, that is still a complex number. And so, again, I don't know if I just learned it wrong at the time or if I was actively taught wrong, but all of them get to be complex numbers. And that was my learning experience for the week while I was preparing for this. So, for today, we're going to spend a little bit more time on quadratics. We're going to spend most of the time on matrices, and depending on time at the end, we may spend a little bit on composite functions. So that is the plan for the day. Oh my goodness, that's terrible. This may drive me nuts today. I'm going to go trade that out. All right, so for quadratics,
Are we like taking notes, or is there like a book you want to step out?
honestly, you take whatever notes you think that you need. Honestly, scratch paper is going to be more important than notes. You're going to give your best attempt to do it on your own if you need to write something, but again, with quadratics, there are some that are very much calculation based, find an answer, and there are some that are more theoretical, and there it's not that writing helps you so much. Here, we'll try a different color. So, if I am giving you this graph, and we have a series of parabolas all on the same graph, the question asks which equation best matches the situation for all n greater than 1. We have -1 over n x squared plus 1. We have x squared plus n. We have -n x squared plus 1, or we have n x squared plus 1. And so here, pink is n is equal to 3, the purple is n equal to 2, the blue is n equal to 1. So, of those equations, which one is describing the situation going on here? Last one. Yeah. So, in general, this question is testing if you remember how transformations work on quadratics. If you change the number here in the front, it's a scalar multiple. If you change the number at the end, it changes the y-intercept, or the crossing point, the height. And if we changed before we took the square, before we did the operation, that shifts things left or right. And that is applicable for quadratics, but it is also applicable for lots of other functions. So if you have an x to the third or an x to the fourth, those same transformations will hold. And how many of you have dealt with graphing sines or cosines yet? That one tends to be more towards after algebra 2, pre-calculus of some sort. Even if you've never seen that before, it's going to affect the graph the same way. If you've got a multiple in front of the operation, in this case sine, it's going to stretch it up and down. If you change it inside the operation, it shifts it left and right. If you change it at the end afterwards, it changes where its height or its middle point is. And so those transformation rules hold no matter what operation you're doing. And so even if you've never seen that before, you may be able to figure out that new sort of problem. Again, I told you I've been doing a survey of problems. The chances of you seeing a sine graph is about 1 in 3 that there will be one problem. And so it might be there, it might be not, but if you have the math knowledge, a lot of times you can figure out even if you've never seen it before, because you can generalize. So that was our first quadratic. The second one is much more calculation based, and I'm not going to draw out the story problem. Oh, much better. Might have to fire that black marker. So, story problem says that the braking distance in y feet, and so I'm going to label this brake distance, for Damon's car to come to complete stop is modeled by y equals 3 times x squared plus 10x all over 40. They give us this equation where x, the speed of the car in miles per hour. So, according to this model, which of the following is the maximum speed in miles per hour Damon can be driving so that the braking distance is less than or equal to 150 feet? Brake. So, they give the options. I can think of 3 different ways to solve this problem. I'm honestly not sure which one would be the fastest. So, what's one way?
Plug in 150 for y,
Okay, plug in 150 for y.
and then just solve.
So, when you are solving this, I would very much multiply by the 40 first, and possibly divide by 3 and just deal with the decimal, rather than trying to do the factoring and that sort of thing. But you could also multiply that in. Both of those would work. What are some other ways you could solve this?
Plug all your answers in to see which one.
You could plug all your answers in. I would go for a variation of that. I would enter this into the graphing calculator and use the table button. Remember, the table plugs in all of those answers at once. You can look at the table and compare the y values. Remember, you're looking for the y value of 150 feet and which x value goes with it. And so if you chose to solve it, it wouldn't be bad. It just would probably be the slowest method on this particular one. But hey, if you can do that, then you are ready to do that when they throw a whole bunch of letters at you and it's purely showing that you can solve it and there's no number answer to be had. And so they ask questions both ways. Again, they're interested in showing you the concepts of how these problems work, and also just get an answer. Oh, shoot. So, out of curiosity, what answer do you get?
40.
40? And again, you could always plug that in to double check, but that is what's going on. So, last one that's going to come up with quadratics is kind of a combination of quadratics and beyond. And so wanted to talk about what's going on there. Yeah. We have for all x greater than 21. We have x squared plus 8x plus 7 times x minus 3 all over x squared plus 4x minus 21 times x plus 1. And they want you to simplify it. Does anybody know where to start?
Try to factor the different columns.
Yeah. What this is going to be using is the idea that anytime you have the same factor on the top and bottom, it doesn't matter if it's a number or if it's a binomial with an x in it. Anytime you have the same thing on the top and the bottom, you can cancel it out. So you could factor this from scratch, but one of the useful things is you know that it's leading to cancel somewhere. So that means one of your factors is probably this thing down here. And so that can give you a boost on what you're doing here as far as, okay, x squared plus 8x plus 7 factors, the only ones possible are 7 and 1. 7 and 1 do add up to 8. Yeah. So we have x plus 7, x plus 1, the x minus 3 hangs out. But the same way here, they have this x minus 3 here already. It's a big hint that it will probably factor out of that one, and so it can help your factoring. What are the factors of negative 21 that add up to 4?
7, negative 3.
7 and negative 3. And so we have x plus 7, x minus 3, and the x plus 1 is still there from the previous thing. So here, what's our final answer? 1. Everything cancels, and when everything cancels, there's an understood 1 left behind. X plus 7 over x plus 7 cancels. X plus 1 cancels. X minus 3 cancels. It equals just 1. When you do cancel, reminder that even if it cancels away, it's still going to be part of that domain or possible x values that work. If we have this canceling out, our answer is 1, but it's also 1 as long as x doesn't equal 7, well, it's negative 7, doesn't equal 3, doesn't equal negative 1. And so that was the reason for the beginning that they gave this caveat for all x bigger than 21. They just eliminated concern about that. But there may be another problem where it's important to know it's undefined at those numbers. It doesn't exist. All right. Any other questions on quadratics? Okay. We're going to go ahead and move on to matrices. I believe it's page 8 in the booklet if you want to... No, not page 8. Where's matrices? Page 8 is quadratics. Matrices, page 12. So, I'm going to ask for answers from online as well. How many of you have not seen matrices before? Anyone at all? Okay. How many of you haven't seen matrices since last year. Okay. So, a matrix is a way of organizing information, and most importantly, it's a way of organizing information that share a certain characteristic but have different values in another direction. So they could all belong to the same family, but they'd be different ages. Or they could all be at the same store, but have different prices. They're always going to have something in common, and then something that is different. The common gives them their column or row. The differences is what gives it a new element of information. So that's the background behind matrices. Matrices will always have only numbers. They could be labeled as money or hours or any value label gets left behind when you put it into the matrix. The matrix is purely math. So it's made up of rows and columns. There's an N in there. Rows and columns. And it's important that when you're talking about the dimensions or the size of the matrix, it's always rows first, columns second. And so that's how you can define the size of it. The reason I emphasize the size is because there are certain rules about what can be combined, what can't be. So if I give you the matrix and I tell you that this is matrix A, do you remember how we would list this 21? How would we tell ourselves to use that piece? Okay, so it's listed as an element or a piece. This is matrix A. The piece that we're talking about happens to be in row 2 and also column 2. And so A22 is equal to 21. A23 would be row 2, column 3, sorry, and that'd be 5. And so, again, row comes first, column comes second. You're just listing each piece. So, first one is adding and subtracting matrices. If we are going to add and subtract them, what condition has to be met? Same rows by same columns. They have to have the exact same dimensions, and those dimensions have to be in the exact same order. Same exact rows, same exact columns. And so, where did that one go? Given two matrices, 9, 8, -4, 7, added to -6, 6, 5, 4, what would the sum be? You got it? Okay. So, when you're adding, you just add the corresponding pieces, which is why they have to be the exact same size, because if one has 2 columns and one has 3 columns, there's no corresponding piece. And so, take 8 plus -6 becomes not 8, 9 plus negative 6 becomes positive 3, 8 plus positive 6 becomes positive 14, negative 4 plus 5 becomes positive 1, 7 plus 4 becomes positive 11. So, when we multiply matrices, there are two different types. One of them is called scalar. One of them is true matrix multiplication. If we have a scalar multiple, it gets stuck outside of the matrix, or it could be written as 3b if b happened to be that matrix. What does that number written outside mean? The name scalar is a bit of a hint.
Isn't it kind of like a multiplication indication?
Yeah, it's a multiplication, but more particularly, it's a scalar multiplication. Scale means we multiply everything by the same thing, if you think about scale drawings. And so scalar multiplication, this 3 is just multiplied by every piece inside here. And so 9 times 3, 8 times 3, negative 4 times 3, 7 times 3. It just multiplies everything by 3, and you can then move on and still add or subtract, do another operation. True matrix multiplication, however, is a little bit more complicated. So, I'm going to call this A and this B. When you multiply matrices, you're going to multiply the corresponding row with the corresponding column, and then if there is more than one piece, you are going to add them together. And that sounds a little confusing, so we have A times B is going to be, is going to be, A is a 3 row by 1 column. B is a 1 row by 3 column. How large is my answer? 3 by 3. The inner dimensions have to be the same. I happen to pick both numbers being the same for future things, but the inner numbers cancel out. The inner numbers have to match because those are what we'll be multiplying together. The outer numbers tell us what our final answer is. And so our final answer is going to be 3 rows by 3 columns. The best way to remember multiplication is that your answer comes from what this position is. This is our first row, first column. So we're going to take our first row, 5, times our first column, 2. 5 times 2 is 10. In matrix multiplication, order matters incredibly much. We're going to have first row, second column, 5 times 7 is 35. First row, third column, 5 times negative 4 is negative 20, and so on. By doing a simple change, changing the order, and making this, I want B times A, doesn't matter what order they're written in. Now we're going to say B is first, this is a 1 by 3, A is second, it's a 3 by 1. The insides cancel out. B times A is going to be a matrix of 1 element. We will get one single answer just by changing the order. So again, row B times column A and we're going to add the elements. So here, we're going to take B times A, so we'll take 2 times 5 is 10, but then we will add 7 times 3 is 21, and we will add -4 times -2 is 8. And we will combine all of these together. 8 plus 21 is 29, plus 10, 39. So, when you are multiplying, you have to do the entire row by the entire column and add them together. It's just in our first example, there happened to be one element in each row, one element in each column. And so, entire row by entire column. Don't let that get lost in the shuffle. So, it's a good example, but I don't have time to write it all up, so we won't do that one. Questions about the multiplication. So again, keep in mind, the insides always cancel out. The outsides tell you how big your answer will be. And this, if this is the first row, first column, says use the first row and the first column of B and A. The rows will always come from the first matrix, columns always come from the second matrix. Anything you can do to cement that in your brain makes it a lot easier. All right. So, unfortunately, you guys don't have this book, otherwise I could tell you to just flip to it, but I'm going to do page 710. What is the product?
3 by 3.
That's the size of it. You still have to find the answer though. But I agree. Knowing what size it is eliminates 2 of the possible multiple choice answers from the beginning. Got an answer? Okay. So again, he's correct. You would be getting an answer of 3 by 3, which means you have 3 rows, 3 columns. The first element comes from the first row times the first column, it's just 2x. Next one down, second row, first column, is just 3x. Third row, first column, is just 5x. Middle column's even easier. Middle column comes from the first row times 2x is still 0, times 3x is still 0, times 5x is still 0. And then a negative 1 times 2x, we have our first row, third column, is negative 2x, negative 3x, negative 5x. So, when they have these, the multiplication takes longer. You get 9 separate answers, but they're 9 really easy answers to get to. The one over there is the most challenging matrix problem I could find. It's not hard, but it's one of those that it's feeling clever and delighted with itself. So, again, how large a matrix is our answer going to be? What will the dimensions be?
1 by 1, right?
Yeah, 1 by 1. And because it has to equal 18, notice this is a 1 by 1. So, ignore this up here for a second. Can you multiply that out? Yeah. Because we have 1 by 3, 3 by 1, these cancel. We have our 1 by 1. Remember that we're going to be multiplying corresponding elements and then adding them together. So we have x corresponds to 6. We're going to have 6x plus 3 corresponds to y. We have 3y. We have z corresponds to 12. We have 12z, all equal to 18. So, now we have gotten out of, just making sure it's on the screen there, now we have gotten out of the matrix part and into, again, number sense. If 6x plus 3y plus 12z equals 18, how can we find 2x plus y plus 4z?
Divide that bottom one all by 3.
Divide the bottom one all by 3. 6 divided by 3 is 2x. 3 divided by 3 is 1y, or just y. 12 divided by 3 is 4z. And 18 divided by 3 is 6. And so if they want to evaluate, we have no clue what x is. We have no clue what y is. We have no clue what z is. But altogether, we know that this would equal 6. Again, I did a lot of these the past couple weeks. There are a lot of ACT problems that throw variables at you, and you have no idea what the value of the variables are. But you can make a generalization about this combination of variables has to be this. It comes up in the geometry ones a lot with adding up to 90 or 180. All right, so last thing with matrices. Can you remember how to find the determinant? Of the matrix problems, find the determinant seems to show up about half the time. And so my powers of prediction says you've got a 50-50 chance of having it on a test.
Isn't it like, if it's a 2x2, you take the corners and multiply them and then subtract them from each other?
Yes. So the standard matrix, they just throw letters A, B, C, and D. If you remember cross multiply and divide, I memorized determinant of a 2x2, and that's the only one they're going to ask you for. They do not ask for 3x3s. Cross multiply and subtract. You're going to take A times D and subtract B times C. There are two ways they may introduce it. They may say find the determinant of, or they may just give it to you like this. Those little straight bars without the notches mean take the determinant of it. And so that one's not hard, it's just, what was that again? It means find the determinant. So, oh, 98, not 89. As near as I could tell, these were very straightforward. I did not find any that had fancy word problems. I did not find any that were being particularly clever. They just literally say, find the determinant of. So, we have the matrix 5, -4, 3, and -6. Find the determinant of. Yes.
This is subtraction, right? Like after you multiply it?
It is subtraction after you multiply. Be careful with signs.
Okay.
So this holds for slope and distance formula and a lot of other things. But remember that subtraction in formulas doesn't mean necessarily that you will subtract in your calculation. If we have 5 times -6 gives us -30, we have minus 3 times -4 gives us -12, and it turns into -30 plus 12, which gives us -18. So that kind of sign error is the one that is easy to trip up. If you're doing it in a calculator, go ahead and type minus negative. Anything that can keep you on the right track. So again, practicing one more just because there were a lot of them. 45. That's all they give you. So, again, we don't even have negative signs to fight on this one. 20 minus 16 is 4. Okay. Again, I have done grand total of 7 tests. Not all of them, I didn't take all of them, but I have gone through and surveyed the types of questions. No solving using inverse. I know that you did that when you had it. They don't put it on the test. They're much more interested in determinants, multiplication, a little bit of adding and subtracting. There's a longer one that I will maybe put up or send to the chat later because it's a good one to look at, but it's not one that I can copy out on the board. It would take me all the time to write it. But there are some that involve more of the story problem situations, cost of different items at different stores, but they're just going to go back to that multiplication. All right. So, last 10 minutes. You guys are in advance. So, linear equation. Pretty familiar. Function notation. Still familiar. Multiple functions, gonna have different letters. How much have you done with combining functions? Have you seen anything like f of x plus g of x? Yeah? Kind of getting to get to that? All right. Here, the sum, the subtraction, even multiplication and division, it's not hard. It's still just glorified substitution. You're going to take f of x and replace it with this function. You're going to take g of x and replace it with this function, and you're going to simplify. The two, well, really one, that in talking to students they haven't been learning as much lately, and so I wanted to check in that you guys had done it, is composite functions. Have you seen that?
Yes.
Okay, good. So with composite functions, you're just taking the function and putting it inside the other one. Have you seen that? Okay, then we're doing good. In that case, I will just pull open a couple. Where'd that one go? I'm sorry, I thought I had these written down and I'm not finding them. Where that one was. All right. No, that's not it. Erga. All right. Here was one. It said if f of a equals a squared minus 2. Find f of a plus b. This one goes back into our quadratics as well. What have you got?
A squared minus 2 plus b. Oh,
Close. You're thinking on the right lines. So, remember, anything inside the parentheses has to go in for the placeholder. And so this would be the entirety a plus b squared minus 2. And so you would have to use the FOIL and multiply that out. You'd end up with a squared plus 2ab plus b squared, and then the minus 2. All right, so last one, again, when I saw this one, it was one of those, I had forgotten that, I didn't think about that, but it does come up. So they tell us that f of x plus y is equal to f of x plus f of y. And they ask us what is or are the possibilities of f of 1. They give us the possibilities of any real number, any positive real number, only 0 or 1, only 0 or only 1. What is the possible answers of that? I'll give you a minute to think about it, and then we go to take a break. But other than the one I started with the complex numbers that I was wrong about, this was probably the hardest problem I found. It was interesting because it was only halfway through the test. Usually they stick the really hard ones at the very end, but sorry, I'm not meaning to be mean. So, if we look back at the one that we just did, where we had f of a plus b, notice it didn't come out to a squared plus b squared. It had the FOIL stuff in the middle. And that is important because by telling us that x plus y is the same as this plus this, what they're telling us is that it's a linear function. The only way for this to be possible is if the original equation, f, gives us a straight line. So, if it's giving us a straight line, we have a straight line. And so it's possible y values go from negative infinity to positive infinity. And it is the all real numbers option. Again, they're being delighted with their own cleverness, but give it your best shot and move on. Don't give that all your time, especially where it showed up in the test. If you spent too much time on that, it could tank you. Mark it, go back if you've got time, but it's not worth your mental effort if you're lost. Give it your best guess, move on, come back if you have time. Number one math tip I can give you: do not change your answer unless you can say why you're wrong. Your gut instinct is usually correct. And so unless you can say, no, I was wrong because I did this, leave it alone. All right, go ahead and take a 5-minute break. In other news, all of this studying, I found a question that was wrong, and it took a Facebook math group like 2 days to argue out about why it was wrong and why it couldn't be done. So that was